So girls, this is my final spiral math video of the year. We're going to be going over both Thursday and Friday spiral math for Thursday, May 14th and Friday, May 15th. So I want you to make sure you have your Friday spiral math done before you check it and before you're watching this video. So we'll go ahead and get started. Oh, there's my TIE fighter going. I better turn that down so it doesn't bother anybody. There we go. All right, let's go ahead and get started. We'll start with number one. On Thursday, centimeter cubes were used to build the rectangular prism shown. What is the volume of the rectangular prism? So basically all we do is we make an answer sentence. We say that the volume of the rectangular prism is, and then they said that there were, oh, now I see it. The unit of measurement that they used here was centimeters. So that's what I'm going to use for my answer sentence. I'll say that it is blank, and then I'm going to put cm for the abbreviation for centimeters and a little cubic centimeter right there to show the little tiny 3 that shows that the centimeters are cubic centimeters. Now, the question is, what is the volume of this? How do we find that out? Well, basically what we do is we just figure out the volume. We could do it one of two ways. We know that volume, and I think I'll do will do the easiest way to do this one. I know that volume is the length times the width times the height. So what I need to do is I find the length, which is side to side right here, and that is 2 centimeters long. There's 2 cubes. On the volume, or not the volume, the width, which is front to back, it is 1, 2, 3, 4 centimeters. So the width is 4 centimeters. So 2 times 4. And then I'm going to multiply by the height. The height is from the top to the bottom. 1, 2, 3, 4, 5. So from the top to the bottom, it's 1, 2, 3, 4, 5 centimeters. So the volume of this rectangular prism is found by multiplying length 2, width 4, and height of 5 centimeters to get the volume. So 2 times 4 is 8. And then I'll multiply by 5. And that ends up with 40. And I want to use the unit of measurement here as 40 cubic centimeters. And that's how we solve number 1. Let's take a look at number 2 for Thursday. On number 2 for Thursday, we're going to be completing the expression 6 liters equals blank milliliters. So I'll write 6 capital L for liters equals blank, and then little m, big L. And the little m stands for milli, and the big L stands for liters, and that's milliliters. Now, if you remember what Ms. Garcia told us about King Henry died unexpectedly drinking chocolate milk. That's going to help me decide how I'm going to convert this. Liters is the unit of measurement, the U in the middle. M stands for milli, which is down here at the very end, for milliliters. So what I'm going to be doing is I'm going to be going from our unit of measurement here, liters, down to a smaller unit of measurement, which is milliliters. So what I'll be doing is I'll be skipping 1, 2, 3. I'll be making 3 jumps down. What I do is I take my 6, I'm going to add a decimal at the very end for 6 liters. I'm going to annex a couple zeros to make it easier to move. And then I'm going to move 3 spaces to the right. 1, 2, 3. And I'm now down here with my decimal, which means that 6 liters is equal to 6, and I'll put a comma in, 1,000 milliliters. All right, let's move on down to number 3. Number 3, they're asking for the prime factorization of 36. So I'll write in my answer, the prime factorization of 36 is. And what I'll do is I'll leave a blank there for my prime factors. I'll go over here and I will write out the factor tree. I'll start off with 36, and I can pick any two numbers to begin with that make 36. The first one I thought of off the top of my head was 9 times 4. It really doesn't matter which two numbers you use as long as they multiply up to get 36. Well, 9 is not an even or not a prime number because I know that I can have more than just 1 and 9 make 9. I also know that 3 times 3 makes 9. Now 3 are both prime numbers. Only 1 and 3 are factors, so I'll stop there with that. But here with 4, I can make 2 times 2. So I'm going to draw a multiplication sign here. I'm going to add my 2, another multiplication sign, and 2. So that we have 3 times 3 times 2 times 2. 2 and 2 are both prime numbers because you can only multiply 1 and 2 to make 2. So now I have two sets of factors. I have 2, which I'll put in order, and 3. Now, 2 I used twice, so I'm going to put 2 to the second power. Then I'm going to multiply it by 3 to the second power. And I can check this. 2 times 2 to the second power is 4. 3 to the second power is 9, which is the same as right up here, 9 times 4. So my prime factorization of 36 is 2 to the second power multiplied by 3 to the second power. If you did it that way, that's great. You could also set it as 2 to the second power, comma, 3 to the second power. Either one's okay. Let's go on down to number 4. We're going to round to the place indicated. We're going to be rounding to the ones place, so I'm just going to put here as 0 and 79 hundredths rounded to the tenths place is, and I'm glad you're doing an answer sentence on this one, boys and girls. 79 hundredths rounded to the tenths place. What I need to do is make sure I take a look at my 7, which is the tenths place. I'm going to make sure that, I'll just write it over here, it might be a little easier to see. So I'll take 0 and 79 hundredths. I'm going to underline the 7 in the tenths place. I'm going to look at the 9, which is in the hundredths place to the right. 5 or more, raise the score. 4 or less, let it rest. Well, 9 is definitely more than 5. So I'm going to go ahead and round the 7 in the tenths place up 1 to 8. So 0 and 79 hundredths rounded to the tenths place is 0. I'm going to keep that 0, keep it decimal at 8. And I don't really need the 0 after it. I just leave it as 0 and 8 tenths. I'll put a period for the end of my answer sentence. All right, let's move on down to number 5. I'm going to flip the page over for this. And I'll move this up. On number 5, we're going to be dividing. And our dividend is 797. Our divisor is 16. So I'll write out my expression like this, and then I'll divide over here going sideways using the dividing box. I'm so proud of you boys and girls for dividing using the dividing box. I've been really trying to do the same thing, making sure that I keep it sideways because actually it makes it a lot easier and I've made less calculation errors when I do it nice and neatly this way. So I'm going to go and go quickly through it. I can't divide 7 by 16, so I'll put an X over it. I'll draw out here and make 79. 79 is bigger than 16, so I can do that. I'm going to multiply 16 times 5 just to see if that's going to be what I want to start with. 6 times 5 is 30. Carry the 3. Oh, it's 80. Oh, 1 too big. But that's okay, because now I know that I'm going to go 1 lower, and that should make what I need. 16 times 4. 6 times 4 is 24, and 2 is 64. So I'll go ahead right now and I'll multiply 16 times 4. That'll get 64 as my product. I'll subtract from 79. 9 minus 4 is 5. 7 minus 6 is 15. 15 is less than 16. It's a big remainder, but it's still less than 16, so it's okay. I'm going to drop down the 7. And now I have 157, which is, let me see here, 16 times 5 is 80. And 16 times 10 is going to be twice that, so it's 180. So 100 and, no, I'm not 180, I mean 160. 160 is pretty close to 157, but it's a little too big. So I'll just go down one more. Instead of 16 times 10, I'll make 16 times 9. 6 times 9, and right over here, 6 times 9 is 54. Carry the 5. 15, or 4, 9, 1 times 9 is 9 plus 5 is 144. All right, I'll go ahead and subtract underneath here. 155 minus 144. Yep, 7 minus 4 is 3. 5 minus 4 is 1. So 13 is less than 16, so that'll work okay. I'll go ahead and put 16 times 9 right up here. Make sure the 144, put the 13. Now in this one, boys and girls, since we're not using decimals, you just leave it as a remainder right now. So 797 divided by 16 is going to equal 49, remainder 13. Thank you for showing your work right here, boys and girls, so you can check and see if you made any calculation errors or copy errors. I'm going to go on down to number 6. 6 doesn't really have any math work to do, it's just asking a question. Which operation is necessary to convert a larger unit to a smaller unit? That can be anything. Yards to feet, feet to yards. Well, actually, it'd be a larger unit, which would be yards to feet, miles to inches, liters to milliliters. Anything that's going to convert from a bigger unit to a smaller unit. And the answer to that one basically is, you would say here to convert, and you could use this a little bit differently than mine, but the keywords here are going to be convert, a larger unit. You want that word large, those words larger unit. To convert a larger unit to a smaller unit, comma, and you could write this differently, but just make sure you have larger unit and smaller unit. You would, and you could change that to it as anything you want that would make sense. I just use you would, and you would multiply, or you would use multiplication. To convert a larger unit to a smaller unit, you would use multiplication. So that is the answer sentence. And again, multiplication is the key word here, and larger unit to a smaller unit. Make sure you have those in your answer sentence. All right, let's move on down to number 7. Now, number 7, we're going to be writing the correct name and place value of the underlined digit. So I'll write here the name of the underlined digit is and the place name of that is hundredths. When I look at that, I can tell it's between the thousandths and the tenths place, so it's the hundredths. Make sure you spell that TH at the end, hundredths. Place is hundredths. And the value, you can either write it out in word form or standard. I'm going to use standard. And the value is 0 and 5 hundredths. Make sure you have the word value in there, hundredths, underlined digit, and the standard form in 0 and 5 hundredths. For the next question, number 8. I'm going to go ahead and zoom in on this so you can see that shape we're talking about here. All right, it's a little bit easier to see now. Okay, now we're going to describe the faces, edges, and vertices of the three-dimensional figure. Then we're going to underline it. When they talk about underlining, or when they talk about describing them, we're just counting the numbers of them. So what I'm going to do is I'm going to first put the faces and a colon. I'll put edges and a colon, and vertices and a colon. and I'm going to count them. Now the faces are, well, I wish I could spin this little shape around, but I can't, so I'll just have to do my best to show you what I'm talking about here. This shape right here has faces on it, and the faces are the flat parts here, and here, and here, and underneath, and in the back, and on the side. All these flat faces are the faces. Now when I counted them all up, looked at them, let's see, I've got one underneath, one, and let me count them up. I've got 1, 2, 3, 4, and then in the back is 5, and the other one here is 6, so I have 6 faces. Edges are a little bit easier for me to show on a two-dimensional shape. So edges are where two faces meet, like this face and this face. Right here is where they meet. That's one edge. Now, right in the back and on top is another edge, and on the top and on the side is where two faces meet. And here's where two faces meet here, so that's another one. In the back, that dotted line shows it's the back two faces are the side and the back are meeting. Here's a bottom and the side, or bottom and the back. Here's another edge, and another, and another, and another one. Here's another one, and here's another edge. So I have 1, 2, 3, 4 edges right here. So let me count them up. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges. Next thing I'm going to do, boys and girls, is I'm going to count the number of vertices. The vertices are the corners where 3 edges meet. 1, 2, down here at the bottom, 3, 4, 5, 6, 7, 8. So there are 8 corners, or 8 vertices. So that's how many are on my shape, are 8 vertices. Okay, the final thing I'm going to do is I'm going to identify this. Well, I know that a figure that has 6 faces and 12 edges and 8 vertices, and every single one of the faces are exactly congruent, that means that this is a cube. It is a rectangular prism also, but more specifically, because all the faces are squares, it is a cube. All right, boys and girls, we're going to take a quick break, and then we're going to get right back into working on going over the spiral math answers for Friday. So make sure you have those ready to go before you go on to the rest of the video.